Looks like we're live. Hello everyone, and welcome to yet another creation programming session with Mr. Zozin. Let's make a little bit of announcement and officially start the stream as usual. Red circle live on Twitch. And what are we doing today on Twitch television website? Did I even prepare the description? I think I freaking didn't. Right, but today we continue developing our own manim, but in C with Raylib. And FFmpeg. So today we're doing something special. Today we are integrating our small proof of concept framework with FFmpeg so we can produce the videos, right? Luckily, we already know how to do that because this is literally what we've done in Mutualizer. So we can rip off some of the code from the Mutualizer and just reuse it in our engine, so to speak. Right, and that's going to be basically the topic for today's stream, right? So we're going to be integrating with Raylib. So let's take a look at the Panium. I developed a little bit this thing off screen because, I mean, on top of just developing this thing, I also need to produce animations for my video, right? So I'm also like developing the framework and making the video simultaneously, right? I do these things simultaneously. So I'm a huge proponent of developing the tool along with using that tool simultaneously to produce something. Right, because that's how you create, you know, the tools that are grounded on reality by instantly using them. Right, so essentially you have a particular task, you develop enough tool to solve that specific task, and then you basically try to solve more ambitious task, and you develop your tool a little bit more, and so on and so forth. So it's constant back and forth between developing the tool and then using the tool. Right, dog fooding, yeah, you can call it dog fooding, right? And essentially, like, if you try to first develop an engine and only then, once you developed your beautiful engine, try to produce something, you will never produce something because you can develop your engine indefinitely, right? So you need to develop things with the purpose of producing something as quick as possible. So because of that, like, I developed a little bit of a thing. It allows me to make a little bit of an animation that looks like this, right? So this is basically an animation that I'm probably going to use in my video, right? So it's a basically tape of the Turing machine, right? So right now it just like goes back and forth, nothing particularly special. Maybe it is a little bit too bright. I kind of like this thing being bright, but I also developed like you know, the dark mode version of this entire thing, just for the streaming actually, because majority of the stuff on my screen is dark, so it makes sense for this thing to be dark, right? So I can actually switch the theme in here, rebuild this entire stuff, right, there we go. And it actually restarted the whole thing, but I mean, it didn't really have to restart everything because we can hot reload things. So we can have stuff like this. So essentially, we can just invert the colors of the background and the foreground, like leaving the hat with the same color, right? So that's what we're gonna have today, right? So it would be, as already said, kind of nice. Like, I developed a little bit of animation. Now I would like to render it into an actual video, and we're going to be using FFmpeg for that, right? So the way we're going to be using FFmpeg is basically by generating a frame and piping the frame into FFmpeg. FFmpeg actually allows you to do that, by the way. So I think it's kind of a little bit dizzying that it goes back and forth like that. It will be a little bit better. It will be a little bit better if it actually didn't go back. So I think this is the last two keyframes in here. I'm gonna just disable these specific keyframes, right, and I'm gonna just go here, and now it will create an illusion that it goes to the right indefinitely. Right, so in reality it doesn't really go to the right indefinitely, right? It constantly teleports. You can see that if you like actually like extend the size of the window, but if the size of the window like that, it feels like it's going indefinitely, right? So the way, like, you know, this thing works is that we're going to be taking the current frame of the animation, right? So there is a way for us to render, for instance, into a frame buffer. Then we will take the pixels of the frame buffer and we will start FFmpeg as a child process, as a separate child process with an input being the standard input. And then we're going to instruct FFmpeg, expect us to submit raw frames, and we're going to be literally piping. The raw frames into FFmpeg, and it will simultaneously produce the videos, the encoded videos and stuff like that. FFmpeg CLI is the API, right? So here's the thing: there is a main misconception. People think that you're supposed to use some sort of library or something like that. No, you're supposed to use CLI. People who who tried to use the FFmpeg as a library, their libav or whatever the fuck it is, they went insane, basically. They went completely fucking insane. It's like, it's easier to just use FFmpeg CLI. Like, trust me. It's just fucking easier. So, same with CLI, I wouldn't say so. I think CLI is pretty reasonable, right? Once you understand how that CLI works, it is actually very reasonable, right? So there is a little bit like, it's kind of weird, right? So, but you just need to know the trick. You just need to know the trick. Report it to FFmpeg Twitter. Please don't tell the FFmpeg Twitter. Please don't tell FFmpeg Twitter that I'm using their CLI library right now, CLI tool right now, because they're gonna cancel me. So anyway, let's actually go to Visualizer and see how we do all of that stuff, right? So we literally have FFmpeg header, right? So this is basically like a small sort of library that we developed specifically for doing all of that. So like the API is actually pretty straightforward, right? So you start rendering with a certain width and height, with a certain FPS, and here we provide the sound file, but this is because it's a visualizer. We don't really need a sound file in here, right? So because once I generate like a video clip, I'm gonna be I'm gonna be importing that clip into Blender, where I edit my videos. You can edit videos in Blender, by the way. Blender is not only 3D editor, right? I'm gonna importing this video clip into the Blender, and I'm gonna be overlaying it with the sound there, right? So because of that, I don't really need sound in here. So we're probably gonna just like adjust this implementation a little bit. We're gonna get rid of the sound file and stuff like that. And then what you're doing essentially, you just basically, as soon as you produce a frame, you just send that frame over like this function. That's it. Once you're done producing frames, you just call end rendering. That's it. That's the entirety of this API. So this entire thing will create like a synchronous separate FFmpeg process that will just wait for you to send frames, right? It's also as flipped, right? I don't remember why, right? So because really when you read the pixels, it produces the frames upside down. So because of that, I created a special thing that flips them back when it sends them to FFmpeg, and to emphasize that, I called it flip. Jesus. Software development, am I right? Freaking software development. So it will make everyone insane. So thank you so much, Knupo, for Twitch Prime Locution. Thank you. Really appreciate it. Will this API work on Windows? Well, I guess. I don't know. Will it? I never tried it. Though. So anyways, right. So let me go ahead and just see what we can have in here. So Visualizer, so panim, right? So this entire thing is called panim, and I'm gonna just like copy paste the header in here and copy paste Linux version for now, right? Because I don't plan to use this tool on Windows yet. So, but I mean, the version that works on Windows should just work. All right. So, and then here, how we're gonna be linking this entire stuff? We need to decide. Or like where exactly we're going to be producing the frames. Are we going to be producing them in the main executable, or we're going to be producing that in a lib plug? So let's actually produce all of that in a lib plug. So essentially, I'm going to just add ffmpeg linux.c, and in plug.c we're going to also include ffmpeg.h. In ffmpeg.h, I think I want to get rid of the sound thingy, right? What the fuck is going on? FFmpeg Linux sound file, right? So here is a sound file. We're also getting rid of that. All right. So, and obviously this is not going to compile, but that's kind of the point, right? So I want to go to the compilation errors and just fix all the compilation errors and stuff. Okay. So what do we have in here? Cool. So here we're constructing the separate process in here. So, and we are configuring the input, right? So here's the thing. So here's how FFmpeg works. I already explained how FFmpeg CLI works, but I can explain it one more time because not everybody knows that. So essentially, you provide first the flags for your input, right? So you just provide the flags that describe the input file, right? So here we say the local level verbose, it doesn't really matter, it's sort of like a global thing, right? So we say that the input is going to be raw, the pixel format is going to be RGBA, the resolution is going to be whatever we provided, the frame rate is going to be whatever we provided, and then we provided -i. As soon as you provided -i, the acceptance of the input parameters stopped, and we're waiting for the input path. Right, and so since the input path is going to be standard input, we provide dash. And then all of these parameters that we provided for the input sort of collapse into that one input that we provided. So in FFmpeg, you do not provide each individual flag separately. You provide flags in chunks. That's how you do that. You provide flags in chunks. You just provide the flags and you end that block of flags with -i, and -i is a very special flag that sort of denotes the end of that block. And there you go, you provided the first input of your thing. The first input. Then here I provided the second input without any special parameters, which is like the sound file, right? We don't really need that. Right, and as you can see in here, we provided another bulk of parameters. And it's concluded by the output. The interesting thing about the flags of FFmpeg is that the output doesn't require its special separate -o flag. The output is considered anything that is not recognized as a valid flag of FFmpeg. That's the logic behind that, right? So if you provided something that doesn't look like any of these flags, you probably provided the file path to the output, and thus you concluded the output block. So here we actually provided arguments in two blocks, the input block and the output block. That's how it works. Why is it so complicated? I wouldn't say it's so complicated, actually. It's actually pretty simple. You provide things in chunks. You provide input files and you provide output files. Before input files, you basically configure all of that. And before output files, you also configure all of that. So as you can see, all of these parameters, they are collapsed after you provided this. All of these parameters are collapsed after you provided this. That's it. So it's just two blocks of parameters, simply two blocks, right? So, and here, whatever you provide in here is actually kind of like a global parameters. So interestingly enough, you can have like several inputs, right? And also several outputs, right? It just depends on how you end your block of parameters. How you end your block of parameters. Do you end it with -i path, or do you end it with just path, right? So, so that's basically how it works, right? So, and once you get a hang of it, it's just like, it starts to make sense, right? So, and you can just pick up and understand how this, like, provide these parameters and everything. Yeah, let's actually try to maybe compile all of that stuff, and it seems to be working. Look at that, it seems to be working. So that's about it. Write might not necessarily write all of this, so there's a little bit of a to-dos in here, but that's fine. That is totally fine. We're even using like a Raylib tracelog shit in here. What the fuck? We're integrating with the Raylib logging system. Huh. That is very poggers, my friend. That is absolutely poggers. Okay. So let me actually try to build it one more time. Okay, so now we need to decide at which point we are rendering this entire stuff. Right, so that's a very interesting question in my opinion. How are we going to be rendering all of that stuff? So maybe I'm going to actually look at the visualizer just like to remind myself how exactly it is done. So let's find FFmpeg start rendering. Yeah, okay, so here we start rendering and we switch to the rendering mode. So I suppose we want to find something like send frame. There we go. So we have begin texture mode and end texture mode. Okay, so we're using like a frame buffer texture to render all of that stuff. This is actually super cool. So this is like the texture is called screen. Let me find the plugin here, and there should be something like, yeah, there we go, render texture 2D. Right, render texture 2D. So essentially what we're doing, right, so we're just rendering the whole FFmpeg thingy into that texture. Then we load an image from the texture, getting it pixels, and we simply send those pixels to FFmpeg. And then we unload that image. So we kind of do that on each individual frame, which is kind of meh, but I think the reason why I did that is because I couldn't really work around it in Raylib. So that's probably fine. We can try to do the same thing in here. So yeah, that's actually pretty straightforward. That's literally what you have to do. So yeah, let's go ahead and do that. Still canceling by FFmpeg on Twitter. Okay. It would, honestly, it would be a huge honor if I get cancelled by FFmpeg on Twitter. Yes, it would be a huge honor, because FFmpeg, to be fair, is a irreplaceable piece of software infrastructure. Kind of like in a curl style irreplaceable, but still. The whole FFmpeg development community doing the work that pretty much nobody is gonna do, right? So nobody wants to do that work, and they still doing that, right? So, and a lot of people rely on them, and I'm extremely grateful for them doing that work. And I'm saying that not because I'm afraid of them canceling me on Twitter. I genuinely think so. I fucking think so. Please don't cancel me. Anyway, so let's continue. So let's go to Panim. What if you're cancelled by React Twitter? Wasn't I cancelled by React Twitter a long time ago? Like, I don't remember, honestly. Like, I just don't pay attention to them. If I got cancelled, please let me know, because I have no idea. So someone has to handle 10,000 companies keep making up. Yeah. So that's exactly. Nobody really wants to do that, except them, except that huge community. Right, H2. Yeah. So, like, I have no idea how to write this kind of encoders. Actually, trying to write some sort of a video encoder would have been kind of cool, like as an exercise, just to see how difficult it is, right? So yeah, that would be interesting. So, all right, let's continue. So to be able to, you know, handle all of that stuff, I think I need an ability to maybe, how to say that, maybe render this entire thing sort of separately, because right now when I'm updating things, I'm getting get frame time directly. Oh, I actually do that through an animation update. Right, so we need to be able to update an animation in two modes: in a real mode when we're rendering the frames, and in a mode when we are producing a video where the frame rate is going to be fixed. Because of that, I think you know, delta time has to be its own parameter, right? So the animation update should not rely on specifically frame time, because when we are in a different mode, we're going to be supplying different things in here, right? So let's actually do it like that. So it's going to be GT, and let's try to recompile this entire thing and go to the compilation error. So here, get frame time. Do we actually do DT? No, we actually don't. Okay. So let's try to recompile one more time. There we go. Cool. So that's basically what we're doing in here. And on top of that, I want to take the rendering of the whole scene in here. Let's actually start that scene somewhere here, like so. I want to take the rendering of this whole scene and separate it, put it to a separate function, so then I can call it on demand, so to speak, right, in different modes. So let me see how exactly we can do that. So maybe I'm going to have a function, Turing machine, right, Turing machine tape, right, and in here what we're going to be accepting, we're probably going to be accepting animation, right, which is going to be just A, and probably the keyframes, but I'm not 100% sure. Yeah, we probably do need to accept the keyframes, right, so this is going to be K of S, which is keyframe multiply point, right, so because we're accepting it as a slice, so to speak, we providing the pointer to the beginning of this array, and then we provide how many elements we have in here, right? So if I was programming in Rust, I would just accept it as a slice in here. Unfortunately, we don't have slices in C, so I have to provide it like this. I could have created a separate structure for that, but I'm kind of lazy, so whatever. Right, so, and let me maybe see. So I want to probably move this entire stuff somewhere here, everything related to rendering this stuff. So we clean the background. I think maybe cleaning the background is going to be fine, right? So we're cleaning the background and we're rendering everything else like so. Right, and let's just put it in here. I just want to factor all of that stuff into a separate function. Right, so here we updated the animation, right? So we updated the animation, then we took the animation value, and then we passed the animation to this thing, which probably means that I want to take the animation value inside of rendering of the Turing machine tape, right? So as you can see, I'm literally hard coding specific animations in here. Because the architecture of the whole framework is going to be so your custom animation is going to be DLL, like this SO file, right? So you're not writing the main program, you're writing a DLL that is then used by this engine to either preview this thing or render it, right? So that's basically the idea. So, and depending on like different animations, you're gonna basically have different DLLs, right? So that's the idea, at least, right? So that's the idea. All right, so what do we have in here? So it complains about some scheisse. I don't really know what is it complaining about. So it's complaining about the length. So probably because, yeah, so here we're not supposed to pass it like that. We have to pass it like this. All right, so what's going to be the next compilation error? RW, so we don't have these kind of parameters in here, which is understandable. So we don't have RW, but we need this kind of RW thingy. In all fairness, I don't freaking know. So let me maybe get rid of RW completely and just say that this is going to be parameter of some sort, right? So let's say this is going to be cell width. What was that, by the way? 100, right? So it was 100. Cell width 100 and cell height is going to be 100. And let's go through all of the compilation errors just to, you know, fix everything up. Like everywhere we use RW, we're going to now use width, cell width. And pad is going to be the same. So let me say maybe it's going to be cell pad, right? So cell pad. And where do we have pad? A pad is actually width, 15% of the width. That's what it is. So we take this width and we simply take a 15% of it. So that's what it is. So pad equal, we don't need that stuff anymore, right? So that's pretty cool. So now all of these things are parameters. So cell pad. What's the next compilation error? So this is a width and height. So these are the width and height of the screen, which is also an interesting thing. I feel like this width and height should be also a parameter because in the preview mode, we're going to be changing the size of the window, but when we are rendering the final video, we're going to be fixing the width and height. Because of this stuff, I think it has to be a parameter all on its own. Right, it's going to be float like this and like this. And yeah, because of that, yeah, it's kind of similar to FPS, right? So it's kind of similar to FPS. That's what it is. All right, so what else do we have in here? So this one is basically cell height, right? So this is understandable. So what else do we have in here? So this is a cell width and cell height. What's the next error in here? So cell size is defined somewhere down there. Let's bring this stuff in here, and this thing is going to be basically cell width and cell height. All right, cell width, cell height. All right. Okay, so we have an unused parameter, which is rather interesting. So we, this one is interesting, right? So since we're sort of passing it like that, okay, so maybe this is what we have to do. Yeah. So this is what we have to do. Okay, and this thing was using the so this stuff is rather interesting. So this entire idea of keyframes is kind of painful in a sense that I don't know, man. I don't know. Because it uses a specific window size, but since we're going to be changing it, it's going to be kind of So maybe I'm going to move this entire thing for now to here, right? So maybe I'm going to be moving it to here for now. Then we're going to get rid of this entire thing, and we're only going to be taking into account this kind of stuff, right? So this is going to be Turing machine. Right, this is a Turing machine, so this is internally available, like so. Maybe on top of that, it would make sense to have KFC count, which is the knob array get KFS. There we go. What else do we have in here? So this is going to be RW. That's a bit annoying. So yeah, let's do RW, which is going to be cell width, and RH cell height. So it's a little bit messy, but that's fine. What I'm trying to do, I'm just trying to sort of separate things so I can render these things somehow. All right, just to render things. So I'm trying to get some stuff done. So KFS, and it didn't like requires 2 parameters. Oh, it's not array get, it's array lang. Right, there we go. So what else do we have in here? So unused parameter. Okay, so this is because whenever, okay, we can get rid of that. What else do we have in here? So action update. Yeah, this is annoying, right? So because let's maybe pass delta time in here, like so, Turing machine, and in here, what we're going to be doing afterwards, we're going to be taking this delta time, like so. This one could be just done like this, KFC count, KFS, not KFC. So essentially, we're just passing this kind of stuff, which actually converged to a very nice place in terms of API, right? So here we provide delta time, and the like float of width and height and so on and so forth. And here is the state of the animation, and we're making state of that animation using the keyframes that are inside in here. Okay, so the refactoring kind of converges into a good place that I'm more or less happy with. Frame time, right? So let me take a look. So this is the delta time, and here we're going to be doing get screen width, like so, get screen height. There we go. So let's try to do that, and as you can see, it compiles. Okay, so essentially, apparently what I want you to do, I want you to move everything into a separate function, apparently. So which is fine, I guess. And so in here, do we refer to, Motherflicker found you. So we have to actually do something like that, yeah. So I feel like we should not use the state of the plugin like anywhere in here, except maybe these kind of situations when we need the font, right? So when we need the font, so that's totally fine. Okay, using the font is totally fine. So cool. Now we need to have a render to D-frame thingy or whatever the fuck it is, right? So let's actually see. Right, so this is gonna be Raylib, and let me open this kind of thing. So it's kind of like render texture 2D. Yeah, I can create it. So I suppose I'm going to be creating that thing up front, right? So I'm going to be creating this thing up front. Where is the plugin state, right? So here is the plugin state. So here we are actually loading the font, right? So this is very important for the 0 in the cell and stuff like that, right? If we try to run this entire thing, by the way, we probably should try to run it because we don't know if it works or not. Okay, so it still works, right? So we're loading fonts specifically for this thing when we're using our Iosefka, right? Iosefka, I don't really know how to pronounce that, but yeah. So yes. So by the way, I came up with a pretty cool way to sort of like reload resources and stuff like that. So it's essentially when you are about to like reload the plugin, right? So when you're about to reload the plugin, I unload all of the resources that I have. Right now I only have a font, right? So as a resource, I just unload them. Then in the post reload, I load them back. So that way I can quite easily actually update fonts without restarting and like check things, which is actually kind of cool, right? So I really like this idea. I don't know why I didn't implement it like that in Visualizer, because it's way easier than whatever like asset management system I came up with, right? So but I mean, it's kind of limited, but it's still fine. By the way, you guys remember the problem with the current like hot reloading system is that you can modify things, but you can't update the schema of the state of the plugin. You can't update the schema of the state of the plugin. I came up with a limited way to actually migrate the schema, right? It's not super powerful or anything, but it's a limited way that kind of works. You can actually add new fields to the state. So essentially what we can do, yeah, exactly. So is that like a common thing, right? I think it is a common thing. So essentially we can store the size of the struct, and if after reloading the size of the struct, it is common in WinAPI, I know that, right? So this is basically the inspiration, right? So I just want like one moment, like I think today, right before the stream, remembered that WinAPI kind of stores the sizes of the structure, right? So essentially, if after reloaded we notice that the size of the structure increased, one of the things we can do, we can allocate more memory to accommodate a bigger structure. We can accommodate a bigger structure and just copy the old structure into the new place. And since the new structure is bigger, it kind of works, right? Because we're appending fields at the end of it. Shuffling around fields is going to break it, so that you will have to restart for this kind of thing. But if you just want to append a new fields to the state, right, without restarting, you can probably do that. So I think that's a cool idea, and I kind of want to try that actually. Let's give it a try. Why the fuck not? Right, and you can't remove the fields. That's true. But again, none of that cases are really important. We're not developing some sort of like a service that has to work to 24/7 and never crash. We're not doing that. We just want to have an application that we can hot reload, right? So like once in a while, and if we have to reload the entirety of it, well, fine, right? So but we kind of want to reduce the amounts of time we have to reload it from scratch completely, right? So this kind of thing allows us to not reload it very often, right? So if you just want to add a new field, you can simply do that without stopping the whole process. Like, why not? Why not just allow that? Right. But if you mess with that thing for too much, what in that case, you probably want to restart the whole thing. And that's fine. That's totally fine. Because what we're going to be doing, we're going to be in the runtime just tweaking different parameters, simple parameters, the speeds, the colors, and maybe sometimes I just want to try a new different font. In that case, like adding a new field in here is kind of a useful feature to have, I think it's kind of a useful feature to have. Anyways, so let's give it a try. So when I initialize the plugin, I allocate it, right? Then I check that I managed to allocate successfully, then I zero initialize it. And I suppose after that, I'm going to just set the size to size of the entirety of the structure. That's it. Right, so that's what we have in here. Okay, so when we're doing pre-reload, we are about to get unloaded from the memory. What we do, we just unload all of the resources, right? So things like images, fonts, and whatnot, right? So all of that stuff just goes away. So then on the next load, we can reload them. So in the post-reload, we load these things again. So as you can see in here, right away, we just assign this thing like this. And this is something that we have to check. If the size of this entire thing is less than the actual size of the structure that we have in here, right, so that means the time has come to reallocate this entire thing. So how are we going to be doing that? So let's say we're going to create a P, but actually new P, right? So let's actually allocate size of new P like this. So this is the size of new P. So on top of that, we probably want to, zero initialize it. I know about calc, no need to tell me about that. This is just a force of habit. Then maybe I want to assert that this thing is not equal to null, right? So and after that, I suppose we want to just copy, right, this entire thing. I'm copying P into NP, but I'm using the old size. You see? I'm using the old size. So that's what I do. And then I'm just do NP size the new size. And maybe this is where I probably need to free whatever P I have in here, and then I assign new P in here. So that's what we're doing here. Though, can't I just, wait a freaking second, can't I just like, okay, so this is all cool and all, but why couldn't I just reallocate all of this shit? Right, so P, reallocate, so we have to provide the new size in here. So this is size of Yeah, I can do that. So, and obviously I want to actually assign it like this, and then just assign the... This is much easier. Why didn't I think about that? So, damn. So because realloc also will, you know, clean it up, like, you know, free it and everything. So yeah, that's pretty cool. So we just reallocate it, we maybe make it bigger. So if it's actually equal, that's totally fine. But if it became smaller, maybe we kind of want to crash in that specific case. I think we kind of want to crash. So that means you removed some fields, and in that case, well, oopsie doopsie, fucky wacky, ooh. Right, so. So we can say trace log error cannot migrate to new plugin schema because the size of the to new plugin state schema because the size of the state became smaller. Right, and here we're gonna abort this entire situation. Right. So, and maybe in here we can also do something like a trace log. So log info migrating plugin state schema. So from these bytes to these bytes, right? And in here we can say that, all right, so this thing is that, and we're migrating it to here, like so. Okay, that's pretty cool. So let's rebuild this entire stuff. And let's try to run the whole thing. Right. So why is it standing? I think we broke something. I think we straight up broke something. Like, what the... Wait, what the fuck? So, okay, let me get rid of that. So I'm gonna try to like rebuild this entire thing. Did I do something wrong? Why is it standing? Why is it not updating? It was updating before, but that now it kind of broke. So where did I break it? For fuck's sake. Man, freaking man, what the fuck is going on, honestly? It's so annoying. Like so I'm looking at A, right? So do we refer to any of the A? No, we only refer it in here. So do we update that A? Ah, I think when we're updating this thing, okay, I see. So that means we're, okay, so I understand why it doesn't work, but the question is why it worked before then. That's the real question then. Like, how did it work before then? So I probably forgot to recompile this entire thing. Okay, so that explains it at least, right? So freaking software development, am I right? Okay, whatever. So what do we have in here? Animation value. So so you want me to actually, yeah, okay, so that's fine, that's fine. What else do you want? What else you want? So we actually provide it as a pointer. Okay, that's cool. So it is, finally it is working. Okay, so we fixed it. We figured it out, chat. Everything's fine, So we want to add maybe some sort of like a new thing in here, right? So let's imagine, so we need to maybe get some sort of a emote, right? So what we're gonna take? So Sodin Zezin. So let's actually grab this entire thing. So I'm gonna copy 3 and I'm going to go into the resources, and here I'm going to create images. Right, so I'm going to download this entire image. Maybe I'm going to download it as Sodin Zezin PNG. There we go. Use a new buffer. Okay, so that's pretty pogue. So it's still running, so that's actually pretty cool. So here is Zezin. So the cool thing now, I should be able to go here, and in the state of the plugin, I should be able to say image Zezin, right? And when we're loading the resources, I'm going to say Zezin load image resources images Sodin Zezin. Right, so that's basically what it is. And when we're unloading resources, we're gonna unload actually image p zesin. There we go. So this is what we've got. So now I should be able to maybe try to rebuild just to make sure that everything's fine. Okay, so everything's fine. Fuck. I actually commented out this entire thing. We have no way to check that. Okay, fine, chat. Everything's fine. Everything's fine. So let's go back. Everything is fine. So let's go back in here. And I'm going to restart the whole thing. I'm going to restart the whole thing. So everything should be working fine. Right, so now rebuild all of that. So I'm gonna run the whole thing. It is running, it is working, it is working. So now, as it's running, it doesn't have any image in it. We are enabling all of that stuff back. We are enabling all of that stuff back. And by the way, maybe one of the things we have to do, we also need to be able to convert it to a texture. So we need to have something like texture to dezesin text rather. So, but we are usually not using this kind of style, so I usually say tag, right? So let me see, in arraylib.h, load texture to, yeah, load texture from in. Oh, I can actually texture from file. I didn't know that I can just directly do that, like what the fuck? All right, so maybe because of that, I can just say that this is a texture. Huh. For some reason, I always did this trick where I first load the image and then load... Okay, so apparently you can just load it as a texture. Alright, so we're loading this as a texture, then we unload the texture. That's cool. So, and then in here, when I'm rendering the Turing machine, I can here draw texture. So, and the question is, where I can draw it? Draw texture. So that's the thing. So I can now do p zesin, we're drawing it at 0, 0 with a tint of white, which means it's not going to be modified. So let's go through the compilation errors. Okay, so everything's fine. Now at runtime, I'm reloading the whole thing and I reloaded zesin without reloading the whole application, right? So, and if we take a look at the logs, so what happened in the logs? Migrating plug state schema from 72 bytes to 96 bytes. So it migrated the new schema. So you can modify the state if you just appending new fields at the end of this struct. At the end. If you're doing something else, we kind of don't support that. Especially don't reshuffle them, don't remove them. Right, so if you just appending, you don't have to like restart the whole thing. It will reallocate it and just like continue using it. Pretty sick. Yeah, it's actually pretty cool. Like I came up with this idea today, right before the stream. Right, so it doesn't like allow you to do anything, right? But a limited case, it can support that. Limited case is supported. So yeah, and I suppose if you don't like the structure, you probably have to leave it as it is, right, in the structure. Right, just leave it as it is in the structure until the next restart. Right, so for example, I just disable it and I'm not going to render it, but it's still going to be in the memory. Right, it's still going to be in the memory. So I just reload it, I don't render it, but it's still in the memory. If I want to completely get rid of it, I have to close this entire thing, remove everything related to that and restart it again. So, but that's fine, right? So, you know, it's 2024, just buy more RAM, just buy more RAM. Memory costs nothing, let it leak. We can even try something interesting, like for instance, I can go ahead and literally remove zesin, just see how this entire system reacts. I specifically coded it so it crashes, right? I just want to see if it will crash in this specific case. Okay, so let's remove that and let's remove that. All right, so I'm going to try to restart it. And it crashed. If I take a look at the logs, what does it say? Cannot migrate to a new plugin state schema because the size of the state became smaller. Right. We can also specify like how smaller it became because we print the increase of the size, but we never print the decrease of the size, right? So why not? So ZU bytes, and we can't really detect the reshuffling, right? So, but this is something that I'm okay with, right? So again, it doesn't have to be perfect, right? We're not trying to be like super robust and super perfect. It's a very loose system. It is okay to be super loose. So yes. But in theory, you shouldn't need to crash if you remove them from the end. That's a very interesting idea, actually. That's a very interesting idea. So how we're going to be doing all of that? So, so if you're doing realloc and you're reducing the amount of memory, are you reallocated or not? Is there some guarantee with realloc? This is a very interesting thought, by the way, Angel Caro. This is a very interesting thought. So if realloc doesn't really, but it doesn't really matter. Does it really matter? Wait. I think it's not. Even if it reallocates, who cares, honestly? Who fucking cares? So we can take a look at the main realloc. Like, even if it doesn't reallocate, we can just, yeah, we can just allow that. So because we already kind of have a code that unloads some of the resources here anyway, in pre-reload, we unload the resources anyway. So that means if we had bigger structure and we removed one of the fields, which was, for example, font and or image, on reload, that is going to be unloaded anyway, so who cares? And then it's going to be reallocated, became smaller. That is actually fine. So yeah, we can just leave it as it is. Thank you so much. This is actually super cool. All right, so for some reason I didn't think through that. But now it kind of makes sense. So we can allow shrinking them as well. The only requirement is just like do operations at the end, right? So append to the end, remove from the end, not in the middle or from the beginning or anything like that. So okay, very cool. I approve of that. So yes. So that means it became actually even more powerful now. It became even more powerful. What happens if you remove the field from the middle? I suppose some of the structures will be shifted and corrupted, if you know what I mean. They're going to be shifted and corrupted. So we can take a look. Okay, so essentially you can imagine that you have the following image. So here's the memory. Memory goes from left to right. And in the memory, you have a structures like field 1, field 2, field 3, field 4. Let's imagine that what you did is removed this field, right? What you did is removed this field. So our system detected that, and it reallocated this thing by removing the last field. So now your code looks at field 1, field 3, and things but actually gets the field 2. So happens some sort of a misalignment. The thing may get worse if they are even different sizes, right? So again, what's going to happen is that we removed field from the middle, but the actual memory is removed from the right, and because of that, all of that gets corrupted and messed up. That's some interesting memory corruption, yeah. But that's what's going to happen. That's why I said don't do that in the middle, right? Because we're removing them from the end, and we can't really know exactly what you removed in the middle anyway, right? So we can't know that. So yeah, okay, that's pretty interesting. So what we need to do in here now, we need to maybe start the rendering process of some sort. So when we start in the rendering process, we need to maybe have some sort of like a Boolean field, right? So some sort of a Boolean field, plug rendering. So maybe I'm gonna actually put this kind of stuff rendering, right? So essentially, I'm going to keep all of the resources at the bottom in here, so then it's easy for us to like append them, right? So all of the non-resources stuff, I think I'm going to keep them in here. So this is a very special field. We're going to keep it always at the beginning. This is some sort of state stuff, right? So, and this is the resources that probably the only thing I want to actually append in runtime. Rendering. So, and initially it's going to be just 0. So, okay. If we're doing this kind of thing. So if we are currently rendering, we're going to be doing one thing in here. Otherwise, we're just doing this machine. Okay, this one is rather interesting because instead of rendering, honestly, we could have just used FFmpeg pointer, right? So because it is a pointer, right? Yeah, it is a pointer. So here we just have void FFmpeg, but we return a pointer to sort of emphasize that it is a pointer. All right, so let me see rendering. So we're gonna do FFmpeg in here, FFmpeg like so. And if we are in FFmpeg, right? If we are in FFmpeg, what we need to do, we need to actually first create the frame, right? So we need to first create the frame. Plug, so render texture 2D, so this is a screen. How do I create the screen? Render texture 2D, so I think it's a load render texture. Load render, yeah, there you go. So that's how we do all of that. That's how we're doing all of that. So plug init. Thinking how I'm gonna approach all of that. So maybe it doesn't really matter because what I can do in here is just screen load render texture. Let's actually have the following thing. We're gonna have parameter render width, and render height. So that's what we're gonna do in here. We're not gonna really allow modifying this thing between the reloads, right? So, but maybe that's fine. Maybe we will in the future, but we'll see. So render width. So what's the actual size that we are using in here? I think it's, yeah, it's this one. It's gonna be modified in the future, but it's just like I'm gonna hard code it for like whatever parameter. All right. So let me try to recompile this entire thing. That's cool. And so we have a render screen. So we need to do begin texture mode p screen. I said screen. So this is a p screen. Then begin end texture mode. There we go. And I don't remember, so do we provide any parameter in here? Raylib and texture mode, we don't provide any parameter in here. And we have to do this stuff in here, right? So between these two things. So here we just render it on the screen, and here we're rendering that into the texture. So that's how it works. And in here, by the way, we're going to be passing not the size of the screen, but the render size, render width and render height. This is why I wanted these things to be customizable like that. This is why I wanted to do that. So here we have to provide the FPS, right? So this is going to be something like render FPS, I suppose, right? So this is basically the render FPS. And render FPS, I think, is going to be something like 1 divided by, it's not really a render FPS, right? It has to be render delta time, right? And a delta time is going to be 1 divided by render FPS. And the render FPS is going to be 30. We're going to be rendering at 30 FPS because I usually make the videos for YouTube at 30 FPS. Right, I'm sorry. I have a weak laptop, I have an old camera, so I'm just doing everything at 30 FPS, right? Because I think it's more cinematic, right? So it's more cinematic. So let's continue. So what do we have in here? 24, oh yeah, I have to do that at 24 FPS to be cinematic, god damn. Fuck, 30 is not cinematic enough. All right, so I'll think about that. The human eye can't see more than, anyway, yeah, sure. What's funny is that, like, technically maybe it is true. You can't really see, like, what's going on, but you can kind of feel it. To be fair, actually, you can see. If you insert, like, a 25th frame, you can actually see that something happened there. You literally can see that. Right, but for example, distinguishing between 120 FPS and 240 FPS, you can distinguish that by feel. You will just actually feel that. Right. I have 120 on my phone and I can see very clearly the difference between 60 Hertz. Yeah, you can see that, but not really see that, but feel that. You can feel that. Anyways. So if we are not in the rendering mode, how are we going to be doing all that? So I suppose I already render everything at what? Just like you can't see air but feel air. That's a very good analogy, actually. That's actually a very good analogy. So maybe I'm going to be hot reloading at H, right, and similar to Visualizer, right. So in here, if you is key pressed, key R, right, so if you pressed R, the thing we want to do in here, chat, we want to start the FFmpeg process, right, so we're going to grab this entire thing. We provide render width and render height, render width and render height. Ooh, height I set, height, and we provide the render FPS, so, and we just do it like that. As far as I know, it can fail, if I'm not mistaken. Yeah, it can fail. So if, and do we even report that? So let me see. So if something goes wrong, we do report that and we just return null, which is totally fine, right? So in that case, it's gonna stay null. So that means we're not gonna be in a render mode. So we'll have to check the logs if something didn't work. Okay, that's fine. I'm totally fine with that, actually. So and in here, after we're done with all of that, we need to load the image and send that image. So let me actually grab the code that I have in here. Yeah, so we're first loading the image, right? So we're first loading the image, and then we're sending it. So I'm gonna actually grab this entire thing in here, right? So like this. So we're just loading the image from the texture, then we're sending this entire image to the FFmpeg. So we don't check the result of and rendering because we don't care at this point. Writing a frame failed. So yeah, so essentially ending this thing may fail, but we're ending it because sending the frame failed. Because of that, we don't check whether this thing failed or not, because we already failed. Who cares? There's no point in checking whether this thing was successful or not. Which makes sense, I suppose, which makes sense. Okay, so that's the whole thing. The problem with this entire shit, chat, the problem is this with this entire shit, we don't know when it's over. When the fuck it is over. It's not over till it's over, right? So we don't really keep track of all of that or anything, so we'll see. So okay, so let's try to rebuild this entire, and it seems to be compiling. So we need to figure out like for how long we need to do that. So the animation is kind of anal in that sense. So update value, right? So update value, how do we do update value? It's just a, yeah. Animation update. So animation update, we're updating the animation. So, and the way the animation works right now, it just circles through the keyframes. That's what it does. Maybe one of the things it should do, it should actually tell you that it's, you know, repeated itself, so to speak, right? It should tell you that it repeated itself. Or at least that it is done. So what we do in here, right, so we give the animation, then we get the frames and so on and so forth. And so if the duration of the current animation is greater than the current keyframe, we're subtracting it and we incremented this entire thing. And then we're doing this kind of stuff. We're doing sort of the mode. So what we can do, repeated false. And this is one of the things we're going to be returning in here, actually. Right, so if we're gonna get rid of this mode that we have in here, actually, we're gonna get rid of this mode. If I is greater than KFS count, we're gonna set it to 0 and we're gonna set repeated to true. So then this entire thing is going to tell you that it is repeated, right? So it is repeated. Or maybe there is a better way to do that, honestly. Maybe there is a better way to do that. Essentially, figure out the duration of the whole thing. Yeah, that's a better way to do that. Wait a second. So let's go back. Let's, you know, cancel the whole checking the repetition or anything. Like, fuck that. So it's not particularly great. I don't like that. It just came to me that we can just go for the duration. Right. So that's way better if we're going for the duration. So we need to have a function. We need to have a function that accepts the keyframes. Right, so let's actually do keyframes duration. This is going to be float, and we accept keyframe, KFS, and then size t. Size t KFS count. right, so something like this, and we can just accumulate all of that. So duration 0, like so, for size t 0 kfs kfs count plus I, just duration plus kfs I duration. We're just accumulating all of them and then just returning all this thing. Okay, cool. So we know the duration. KFS. What if we literally make this thing global and accessible to everyone? Because we're not really modifying it per se anyway, right? We're not modifying it per se anyway, so let's keep it like that. So all of these things, this could be just define, which is a little bit annoying, but maybe that's fine. So yeah, I don't like what I'm writing, but I'm not sure if I can like really fix it anyway. I just want to make it work for now. Just want to make it work. So the only thing I'm doing in here is, right, I need to know the duration. So what is going on in here? Is everything okay? All right, hopefully everything's okay. So since we know the duration of the whole animation, right, so we need to keep track of the rendering. So we have a FFmpeg, we have the screen, and we need to know like how much we already rendered, right? So rendering duration. So essentially when we're starting the FFmpeg, we can just do, okay, rendering duration is initially 0, right? So initially 0, we're starting from here. Right, then we update this entire thing, right? So, and then we do p rendering duration is going to be plus render delta time, like this, render delta time. Okay, and here maybe if p rendering duration is greater or equal to the keyframes duration, where we provide kfs and kfs count, this is where we want to end the whole thing, right? This is where we want to end the whole thing, right? So otherwise we just do that. So we kind of want to skip if it's like, if it's done, if you know what I mean. I want to skip this entire thing if we're done with it. There we go. So render duration, we keep incrementing it, and at some point it's going to be fine. So Andy Otter, thank you so much for tier 1 subscription with the message. It's a time for our own Sonzin. I have no idea what that means, but thank you so much for tier 1 subscription. Really appreciate that. All right, so let me try to rebuild all of that. So it is complaining, yeah, because it relies on all of these things and stuff like that. So I'm still thinking how I want to generate all of these keyframes, right? So I can't find the place for them. So right now I'm kind of relying on them being in a static memory, but then it would be better if they were in dynamic memory. If they are in dynamic memory, how do we reload everything? How do we update all of that? So I'm not quite sure. And honestly, I think since the keyframes are kind of hard-coded, they should not depend on width and height and so on and so forth. So it's kind of annoying that it does depend on that. All right, so I think for the sake of just shipping this thing and for the sake of just making this entire thing work, I'm going to literally hard code. We can literally hard code the length of the animation, right? So at least for now, because again, I just want this thing to you know, render a video for me, so we get some sort of a base to work with, right? So 1, 2, 3. So the animation is 3 seconds, right? So the animation is 3 seconds. So let's actually put 3 in here, like so. Right, because I can refactor all of that. I just don't want to spend time refactoring all this. I want to get FFmpeg rendering as quickly as possible once we have it working, then we can finally like make it prettier or something. We need to have something at least working, right? So because otherwise we can get stuck refactoring and refactoring and refactoring, so it's not productive in my opinion. Right, so let's see how it's gonna work. That's pretty cool. And when we're starting this entire thing, by the way, we also need to restart the animation, honestly, right? So we need to do something like maybe memset. So let me take a look at the, yeah, so memset PA, 0 size of PA. There we go. So we just resetting everything to 0. We're just doing that. Then at some point it's going to be fine. And to be fair, maybe after we're done rendering, we also want to reset everything. And by the way, after we're done with that, we have to set this thing to 0. And this thing may fail, by the way. This thing may fail. So I don't really know what exactly we're going to do in here. So FFmpeg, let me find what happens when you fail. So end rendering. So in case of success, it returns true. I guess it doesn't matter. Honestly, it doesn't really matter. Like, we don't really want to handle anything. So if it fails, it will just print that in the log. But we still want to do this thing anyway and continue working. Right, we still want to do this thing and continue working, so that's fine. That's totally fine. Okay, so let's do that, and let me start this entire thing. All right, so we're rendering this shit. Fuck! I remember this shit. Pixel data retrieved. I freaking remember that. This is the most annoying part of Raylib. This is the most annoying part of the Raylib. I hate it. Oof, it is just like, it's so goddamn annoying. Okay, so it logs every time you're retrieving pixel data out of this goddamn frame buffer. So, and like all of these things coming back to me, yeah, holy shit. And because of that, I had to change the allowed log level right before I do the rendering. Oh, this is so stupid. Log level was something like a level. Yeah. Damn, bruv. So I had to start rendering set trace log level log warning. So info is not basically logged or anything like that. I don't know why it is the default in Raylib. I have no idea why. Probably because they didn't think about this specific use case. But I mean, luckily you can work around that, right? So you can work around that, that's fine. So because of that, I'm not complaining too much. I'm complaining just a little bit, but not too much. Right, so we're gonna do that. So we still want to have some sort of warnings, and then set trace log level back to info. Yeah. Once we're sort of done. So but we have to do that like in 2 places, right? So when we're, yeah, I wonder why we don't do that in here, but that's fine. That's fine. So, and honestly, this thing kind of repeats itself, so which means that it's refactorable to a separate function, right? So as you can see, it's basically the same piece of code in here, and in here every time we need to finish the whole thing. So yeah, at some point we're going to factor it out to a separate sort of function. All right, so what do we have in here? So it's going to be that. Let's actually start this entire time. Okay, so let's render this thing. Let's go, motherfucker, let's go. Okay, we're rendering things. It has to be 30 seconds, by the way, chat. Okay, okay, we're done. Are we good? Okay, and we went back to a preview. I'm gonna close this entire thing. Do we have output? We've got output MP4, chat. So let's actually do FFprop on this thing and see its length and stuff like that. What is its length? What's its length? I can't see shites in this mist. 3. Yeah, we overshoot a little bit. We kind of overshoot a little bit, but that's understandable, I think. Right, let's take a look at this stuff. This is a video, chat. This is literally a video. So first try, dub. Resolution is 16:9, but it's kind of like this one. So I don't really want to change it, right? So because the animation is kind of hard-coded around this resolution, so I'm gonna fix up the animation first, and then it's gonna be whatever resolution. So yeah, so I can generate this kind of videos, this kind of video clips, and then I'll be able to export them into the Blender and incorporate them into my videos, into YouTube videos. So that's kind of the point. So yeah, I'm going to be modifying this kind of thing in here, crafting the animation, being creative, right? So I have all of the tools to be creative. I enabled myself with creativity, and yeah, we're good to go. We're Gucci. We are, in fact, Tamaguchi. It took me only 1 hour to implement that. How about that? How about that? So I think the time has come to make what? A small break. The time has come to make a small break and refill the cup of tea. So, okay, meine Freunde. So there is a problem with our keyframes. We don't have a door frames. Sorry. So what we need to do with the keyframes, they are dependent. They're very much dependent on the window size, the cell size, the padding size. Like all of this shit is straight up hard-coded. It's fucking disgusting. I absolutely despise that. I want to burn that code with fire. But I can't, because it's a useful code. So I want to take that code and maybe decouple it from the notion of the window, from the notion of cell size and stuff like that. So what this shit does, it says that I have to move from cell 0 to cell, actually this particular keyframe says that I have to move from cell 0 to cell 0 within half of a second, aka stay on cell 0 for half of a second. Okay, in this keyframe, I say move from cell 0 to cell 1 within half of a second. Then here I just say stay. So the reason why I'm hard coding that is because I'm sort of like using this array as a format, because I plan to maybe also save it into a separate file at some point and then parse it and stuff like that, right? I want the keyframe to be a basic building block of the animation, right? So a basic building block of the animation. I don't know how good of the idea it is, but I think it may work, right? So in the future, maybe we're going to have an editor that will allow you to tweak each individual keyframe. Maybe there will be some sort of like a Bezier curve associated with the keyframe and stuff like that. Speaking of Bezier curves and easing and stuff like that, I recently, like off screen, reintroduced a pretty cool thing. So here's the animation value. So essentially I take a T, which is basically an interpolator from the beginning of the keyframe to the end of the keyframe, and it's a linear thing, it's just a straight line. But look what I do with this straight line. So I take T, I plug that T into this monstrosity in here, and I reassign it back, and only then I interpolate with that. Do you guys know what the fuck is this? Do you guys know what the fuck is this? This is actually pretty cool shit, right? So easy, well, I mean, you can look at the easing, but specifically I'm just using sine, a chunk of a sine function for interpolation. So so sine function. So if I go to Google, maybe we can find the images of some sine functions. Yeah, there we go. So here is a sine function. Can I in 2024 just click on that image and just open it up and conveniently use it? The answer is fucking no. Like, I just want that image. Just fucking give me that image, motherfucker. Thank you. Holy shit, it's so hard. Anyways, so what I did in here, I took this chunk of the function from minus half of a pi to plus half of a pi, right? And what I did is that I remapped it from this rectangle to a value from 0 to 1 and 0 to 1. So then I just have this thing that starts slow, then ramps up, and towards the end slows down. You see what I'm talking about? It's just like... So it feels more natural. It feels more natural. So easing in and easing out. That's what it is. Easing in and easing out. And that's what this formula stands for. And you can disable this entire formula and you can observe very cool results because of that. Right, so now I disabled all of that easing in and easing out. So this is how it looks like. Can you feel that, by the way? Can you already feel that? It's so fucking robotic. It is so freaking robotic. But now, if I go ahead and enable that thing, right? So look. something broke, but now it is more natural because it just ramps up and slows down. See what I'm talking about? So yeah, so this is one of the sort of principle of animation, right? So even the people who are like drawing cartoons and stuff like that, they are aware of the fact that you need to do ease in and ease out for the emotions to be more natural and more pleasant to look at. This is extremely important, actually. So, and the reason why I used the sign is because it was kind of easy to just slap it onto the animation, right? So I just took chunk of the thing. So maybe use sigmoid. Maybe could have used sigmoid, right? And here sign, also fine. So basically anything that looks like this, will kind of work, right? So it will kind of work in here. Square, so you basically suggesting to do square, right? If I understood correctly. So square doesn't have this S shape, right? I'm talking about S shape. So let me actually maybe draw that. So the shape that I want actually looks more like this. Right, so this is 0, this is 1, and this value also goes from 0 to 1. So if you are using square as you suggested, it's going to be more like this, which doesn't feel the same, honestly. Which doesn't feel the same because it's just like abruptly this just speeds up, and it's just like it's kind of weird. We can try that, by the way. We can try that just to get a feeling of how it's gonna go, but I didn't like it. I tried it, by the way, and I didn't like it. Okay, so what do we have in here? So it's a build main. So as you can see, there's no ease in. There is ease in, but there is no ease in out. Just so it's just like it doesn't feel good. Something like this is way better. It's just like ease in and ease out. It's very beautiful. So yeah. So I'm gonna leave it as it is then, at least for now. So I'm actually was using square for eepers. Maybe I should have used this kind of shit for eepers, honestly. For some reason, like, this is only recently I realized that you can do easing in and easing out with this kind of thing. Acceleration, deceleration, exactly. Man, what if I try to do that for eepers? Just a second. Can I? Let's port this formula to eepers, chat. This is a poggers idea, honestly. I didn't think about that. So we have some stuff in here. I suppose it was just experimenting with some things. Right, let's go back. It's stuck. Okay, so let me see. I'm gonna fetch those changes just in case I had any changes recently to keepers. I don't think I did. Okay, so that's cool. So let's do build Linux. Okay. Surprise AD stream. Surprise, motherfucker! Surprise. So just waiting until it's all built. Yeah, I just realized for how long eepers build. Actually, I forgot about that. Especially when I'm streaming, right? Especially when I'm streaming. Okay, so let's start eepers and just see. Yeah, doesn't. So we're using square, if I remember correctly, right? We're just using square for this kind of stuff. Okay, so if I go into the source code, eepers ADB. I don't quite remember where was the function that was doing interpolation. I remember that. Somebody accepted that. So in the game state, we have turn animation. And where do we use that turn animation? So we have a thing called interpolate positions, and in here, okay, look at that. We're just doing this kind of shit, which is understandable, which is actually understandable. So let's go back. So I'm gonna open plug.c and I'm gonna grab this specific formula. And I don't remember like synth, right? So we have synth. So here we take pi multiplied by t minus half of a pi. then we have to, so we have a stuff from -1 to 1, so we're bringing it to 0 to 2, and we dividing it by 2, like so. And so this one is going to be something like this. So this is an alternative to this stuff. We're also kind of inverting it, right, because it goes in a different direction. So it goes in a different direction. So let me see. So it's probably not going to compile right away, because we don't have a couple of things. We don't have synth. We don't have synth. We do have florf, like so. So I might as well actually, in a place where we do synth, I might put this thing in here. So this one is going to be synth, and this one is going to be synth. All right, so I'm using the C function in here. So C float, so T is what? T is just a regular float, so we have to do C float like this. We have to do C float. And in terms of pi, do we have pi? Yeah, I think we do have pi. Okay, so it seems to be building. Half of a pi is tasty. It is in fact tasty. I do agree with that. It's a very quick motion, honestly. So it's kind of hard to tell. So maybe when I need to actually listen. What language is this? This is Ada. I need to try that after the stream. It's very jerky, honestly. So let's actually wait until this thing... It's kind of difficult to tell. So I think the motion is just too fast to tell if there's that much difference. So because of that, I think I'm not going to incorporate that. But I'm also going to try to do that after the stream when my computer is not that laggy. It looked worse, actually. Okay. All right. So we'll see. So I suppose it depends on the goal, right? So it depends on the goal. For the game, maybe that's better. Like square is better. For this kind of animation, something else is better. So why do you divide by 2 with a half? Because it also works. It's just a style. I think you can say it's just a style, yeah. We can see your cursor. Thank you for reminding me, by the way. Now you can see it. I forgot to enable capturing of the cursor. Right, so you can just... You can't see me. You can't see me. You can see it again. Haha. It's actually kind of fun. I think I disabled for recording something. Right. So I think I disabled to record something. Peekaboo. Peekaboo. You can see me. You can't see me. You can see me. Oh, you can't see. Haha. I'm sorry. Isn't that what you subscribe for? Isn't that the content you subscribe for? This is engaging, right? This is engaging content. I'm a professional streamer. So funny tea today, yeah. We're just drinking some funny tea. So what am I doing? Yeah, I need to do Nobel. Alrighty. So, what I was talking about the mother flipping keyframes, right? So essentially, what we have in here, we are encoding movement from 0 cell to 1 cell. What we have to do, I think, we have to replace all of that shit with just number 0 to 1 or 0 to 0, 1 to 2 or 1 to 1 and so on and so forth. And I wonder if we can do that using a little bit of a Emacs magic, if you know what I'm talking about. So let's actually find out. So what I want to do in here is just then I want to do and then and then so that's what I wanted. Look at it. Look at it. Isn't that cool? Right. So and it instantly became readable, isn't it? It instantly became readable. So I just say for half of a second, stay at cell 0, right? For half of a second. Then after that, in half of a second, move from 0 to 1, and so on and so forth. So right now, this is not going to work. This is simply not going to work because the movement is going to be very slight. We need to map all of these values now to whatever it was before, right? To actual cell positions and stuff like that. We can try to maybe run this entire thing and see what is going on. We can try to do that. You can kind of feel the movement. Can you see a little bit of a movement? I don't see enough movement, chat. I don't see enough movement. That's kind of the problem. So I wonder if I can actually develop this entire thing now, right, you know, with hot reloading and shit. So essentially, we have this T, right? So which is the actual animation, which is the actual value, like among these values, right? Among these things that we put in here. So where we use that T, might as well maybe put underscore in here so the compiler will actually tell me where it is used. Okay, so T is unused in here. That's pretty cool. Since T now is the index of the cell, what we have to do, we have to multiply it by the cell width, right? So this is a cell width now, right? But it's a cell width only relative to the center of the screen. So, but maybe it's fine. So if I try to just reload this entire thing, and there's something weird in here. When I hot reload, the entire animation stops. I have no idea why. Maybe because I don't freaking know why, honestly. So it still kind of moves around. It jerks around, but I can't see. Oh, because it didn't recompile. Okay, so that's fine. Okay, so let me move this thing in here. So, that's cool. Yeah, and it literally stops. Let me take a look at the. Oh, fuck! I didn't mean to. I forgot that I changed. Okay, so that seems to be working. All right. I actually pressed R and it started like, you know, reloading and stuff like that. Okay, so that's totally fine. That is totally fine. Now, what I want to do, so this is a cell starting from the, you know, from the beginning of this thing. So this is going to be cell width and so on and so forth. So what we have to do, we have to take the size of the screen, get screen width. So we got the rate from OV Rogue. Thank you so much for the rate. So how are you guys doing? So what you guys been doing? So we're doing a little bit of the animation development here, right? So we're animating the Turing machine. It's kind of crappy. The head is not even aligned properly, but this is because we're just like experimenting. Right. All right, so we need to do this kind of thing. So we offset essentially by the half of the screen, and we have to now subtract the half of the cell in here. To be fair, I can actually look up how exactly it was before, right? So because I do have this information. Right, there we go. So that kind of makes sense. So it is offset by half of the screen, then minus the half of the cell, and then we also multiply it not only by half of this, by the size of the cell, but also plus padding. So because of that, maybe in here I have to do cell pad like so, and I think that should be more than sufficient enough. So it doesn't want to work because why? Cell padding. Expect expansion before dot. Ah, yeah, I forgot the closing thing. Yeah. All right, so I'm gonna reload this and everything. It still doesn't work. Ah, fuck! I start rendering again. It's kind of classical situation. God fucking damn it. Okay. All right, so that was interesting. I'm kind of surprised that this was not enough. Like, it's kind of difficult to understand for me, because so we are mapping this entire stuff. So this is multiplied by cell width. Ah, it's still minus. Okay. So hopefully that will work. All right. Still doesn't work. Still doesn't fucking. Why? And it's not even aligned correctly, because isn't that entirely the same formula that I have in here, isn't it? So if I just use T, man, what the fuck is going on? Like, it's like the situation is like, it doesn't work, and I don't even know why. I don't even know why. So screen width. So we were adding this entire thing, so we turned this entire thing into that. And that entire thing is simply just a reflection of that, where we took half of the screen minus half of the cell minus the current index multiplied by the whole cell width, plus the cell padding. So, and it's supposed to work, but it doesn't. What the fuck, man? What the fuck? That is really sad game. That is really sad game. I have no idea why. Anyway, so let me maybe think. So let's actually reduce this entire stuff to something like that. So we rendering this thing, and it's initially gonna be something like 0, right? So it's initially 0. All right. So. So that is bizarre. I didn't expect that to be like that. I definitely didn't expect this to be something like this. So what I want it to be actually is to maybe plus get width, get screen width, and half of that. Let's rebuild this entire thing. All right, and okay, that makes sense. That already makes sense. That is very cool. So let me go now back and just say now minus cell width, and half of that, of course. Obviously, we want a half of that, and now it points precisely at this entire stuff. That is beautiful. That is beautiful. So now if I want to point at the next cell, I have to add cell width, probably, right? So I have to add cell width. Actually, I have to subtract cell width, apparently. Okay. All right. Subtract cell width, but we also need to take into account the cell padding. So plus cell padding. All right. So that's pretty cool. That's pretty cool. So now if I have some sort of an index in here, like for example, multiply by 0, right? So this is going to be just 0. If I change this thing to 1, it's going to be that. So this is the next one, then the next one, and so on and so forth. So that seems to be working. And now we can say that T is that specific index, right? Because it's interpolating from 0 to 0, from 0 to 1, and so on and so forth. Slowly but steadily, we figured it out. All right. So, but we want to kind of offset this entire thing. So there was some sort of, offset 7, right? So this kind of thing. So maybe I'm going to actually put that offset to here, right? So because the reason for that specific offset is because we don't want the left side to be visible at all. We don't want it to be visible, so might as well put this offset a little bit in here. So now if I try to do that, that looks beautiful, and it goes to the right indefinitely. Right. So we achieved the illusion. And what's cool now, chat, is that this definition of the keyframes doesn't depend on anything. We can resize things. It will just basically restructure automatically, right? So before we had like a very sophisticated formula in here or anything like that. But then we stripped it down to just a meaning that is the index of the cell that you have to point to. And we're just saying that you must interpolate between these two indices, and that's it. Right, so that's basically what's going on in here. And I think that's a cool solution, which enables us, chat, it enables us to factor that shit out, finally, to a completely separate function outside of the Turing machine tape. We're putting it outside of the Turing machine tape. Right, so before we couldn't do that because we needed to know all of these like window parameters or shit like that. Like we don't care anymore, right? So it could be a global thing now. It is a global thing, so I'm going to do static. This one can become something like define. Right, so there we go. So all these parameters are kind of stupid, so maybe I'm going to get rid of them at some point. So let me try to recompile this entire stuff. Yeah, we don't even need any of this stuff. It's actually super cool. All right. So, and this sort of like encapsulates this animation. It shouldn't be a static because you can't hot reload. No, I just hot reloaded. Surprisingly. So maybe there was some other problem in there. I think there was some sort of other problem in there. But yeah, anyway, so that's pretty cool. But I want to be able to actually have like separate kinds of animations, right? So we have one interpolator which interpolates like one thing. So we also need other things, right? Because this thing has different parts, if that makes any sense. It has different parts. So maybe I also want to offset this thing a little bit further, especially when I'm, you know, in full screen. Right, so in full screen now it looks okay, right? It actually looks indefinite. So here, by the way, we have 20 elements. We do in fact have 20 elements, but maybe I want to actually have different values within the cells of the Turing machine. That's probably what I want to have, right? Different elements within the cells. So maybe what I need to do in that case is just like store this stuff somewhere. The question is where I'm going to be storing all of that. So how I'm going to be denoting that tape. So let me actually think. So maybe we're going to have a tape that contains integers or strings or something like that. So let's just call it maybe a tape, which is going to be an array. And in here, we're going to just have something like this. All right, so if we're going to have 20 of them, let's do 0, 1, 2, 3, 4, 5. So this is 5 of these things. Now, this is 10 of these things. 10, 20. Right, if I understand correctly, right? So we can even do something like this. 4, it's actually too much. 0, 5. It's actually more than 20. I think I did some fucky wacky, but that's fine. Right, so this is 20. So this is the tape, and here we can do something like maybe excuse me, tape count, which is going to be knob array length tape. So we've got that. So and in here instead of doing this thing, I can do tape count, right? So this is a tape count, and for this text we can just do, I suppose we can just say tape I. All right, that's pretty cool. That didn't change anything, but now we can just try different things. For example, what if I replace 0 with 69, like so? Is it going to actually work? Yeah, it is going to work. It is going to work. So that's a nice tape, by the way. That's a very nice tape. The animation that I want to do is essentially we move to a particular cell. Then we replace that cell with 420 and we move further and further and further. So I want to be able to actually like modify certain things in there, right. And because of that, so this key of S is essentially just the position of the head, right? So maybe we can say this is a head KFS, right? So where the head is currently located, so head KFS. So we also need to have some events, sort of speak, right? So have some sort of events, like for example, when we moved from 0 to 1, and while we're staying from 1 to 1, we want to animate changing the element from one value to another. Right, so that's what I want to be able to do. So, like, I'm still not sure if this paradigm of keyframes is perfect for this kind of stuff. Like, I'm still not sure, but we'll see how it goes. So we replace 69 to 0, and let's go. Let's go. So this is KFC. So this is a head, not KFC, KFS. Head KFS. So it means I'll have to change it in all of these places where I do all of that, right? So this is a head KFS. So that's totally fine. Head KFS, head KFS. That's pretty cool. So if I reload all of that, it's back to 0. It is back to 0. Okay. So how can we trigger certain events, or should we trigger certain events? That's the real question in here. That's the real question. So we can have static keyframe. So essentially that means that within the tape, the tapes themselves should be some sort of objects. There should be some sort of objects that can modify themselves, right? So maybe we literally need to have something like struct cell, right? And it basically has some sort of a value, that interpolates its visual part from one symbol to another, right? So I can already feel that we're kind of moving away from this entire keyframe paradigm, which is fine. I introduced this keyframe paradigm to figure out what I actually need. Right, so that's totally fine. All right. So this one is going to be something like symbol from, and this is going to be symbol to. We're moving from one symbol to another one, so that's what we're doing. And in here, I would say maybe we're going to have like an actual interpolator, right? So it's going to be sort of like a T, and sort of like a duration, right, for how quickly we want to do that. But maybe it's going to be hard-coded, actually. It's going to be hard-coded. So the idea of this interpolator is that if it's 0, the cell must display from. If it's 1, the cell must display to. How quickly it's going to do that, I think it's going to be the same for all of the cells. And the idea here is that, so tape is a bunch of cells, right? It is in fact a bunch of cells. We can even say that it's like 20 cells in here. Right now they're initialized with 0, right? So which is totally fine. They are initialized with 0. So I'm gonna move this tape somewhere here, maybe closer to the plug, right? So closer to the plug, so we have 20 of these things. And when I'm initializing the plugin, right? So when I'm initializing the plugin, so maybe, yeah, I think I need to move this entire thing to here. I think that's going to be a good idea, just to move it in here. So we have cells and there's 20 of them, and they're initialized somehow or something like that. So the tape count, let's say that the tape count is going to be sort of like tape count, count 20, right? So we're going to put this entire thing in here. So this is the tape count. Tape count, that's pretty cool. Okay, and when we are initializing the plugin, we're gonna do something like for size ti, tape count plus I, right? So this is gonna be p tape I. So symbol from. To be fair, honestly, like, I don't know why I added that symbol prefix, right? It's kind of redundant because we know the context. The context is cell, so we know what exactly we're talking about. So from is going to be 69, right? So 2 for 20. And since we're setting everything to 0, so t is going to be 0 anyway, so who cares? Who actually cares? So that's totally fine. All right, that's cool. That is cool. So here is the head interpolator, right? So here is the head interpolator, and maybe because of that, the head itself has to be sort of like its own state, like the tape. Sort of like its own state. So let's actually do. So instead of like having these hard-coded keyframes, I think I need to model actual objects on a scene, like in OOP style, right? So not really OOP style, but I mean, I like instead of having abstract mechanisms that allow you interpolate shit and stuff like that, it's better to have concrete objects, concrete entities, right? So, and that will make it a little bit easier. So I think that's a good idea. That's a good idea, I think, generally. All right, so this is going to be sort of like a head, right? So, and the head itself is going to be basically an index, all right? So, and the question is like what index that is going to be. So should it be something like, yeah, index. And index is a continuous value which allows the head to move between these kind of cells and everything. So it's a continuous index. And it might be in sort of like different states, right? So it might be in sort of different states. So maybe we can do something like head state, or maybe head phase, right? So, and the phases of the head are going to be num head phase moving. HP, we're gonna call it HP for the head phase. So we're moving, and another phase is gonna be writing, right? And the writing process basically substitutes the symbol, and while we're writing, we're interpolating the current cell in here. That actually fits perfectly, I think. That actually fits perfectly. All right, that's pretty cool. That's pretty cool. That's pretty cool. So because of that, right, so since we're interpolating, we're moving from one place to another, maybe what should have we done is something like size t from to, and that's basically the index. If you are in a head phase moving, right, if you are in a head phase moving, you basically moving from that thing to another one, and this one is an interpolator, which indicates like how far along the way you are from to, right? So this is going to be phase, so to speak. So we have a tape, we have a head, there we go, we have these two things, and that's pretty cool. So, and that idea of the keyframes is probably going to be obsolete, but I'm still going to be using some of the cool things in the keyframes that I developed, namely the sign interpolation. Right, the very thing that allows like a very smooth interpolation from one thing to another. So with easing in and easy out and everything. So keyframe. So where is that sign? Yeah. So this one, this one. I feel like I want to factor this thing out to a separate function, right? So something like static float. I have no idea how to call that function, right? So, but I wanted to accept t and simply return this beautiful, beautiful thing, right? I really like this formula. This is a very cool formula, and maybe I'm gonna even help compile it a little bit. And essentially what I want to do, I want to just like do something like this, and I'm gonna be reusing this function over and over again. So how should I call it? Nice interp, I don't know. So maybe synth interp, right, something like synth interp, synth interp. Right, and it's so cool because now I can use it everywhere. Every time I need to like a very nice interpolation, I can just use that, and that's pretty cool. So sinful interp, maybe. So isn't smooth step basically that? But it's just like a different formula. Smooth. I don't remember how smooth step in GLSL looks like. Smooth step. Does anybody remember? Smooth step. Oh. Smooth step is basically segment, isn't it? Wait, this is a smooth step, and it's actually. So this is a. Where's the smoothest? Where's the smoothest step? I swear, I didn't expect to see that in the smoother step. Not a mathematician, yeah. Smooth step, smoother step, the smoothest step. Wife exits. Yeah, wife exit. Yeah, I remember that one. I remember this one. Smooth step. And what this one does? It's basically cubic. Yeah, it is cubic. Look at that. Look at that choice. It is cubic. Maybe I should use this one. You know what? That gave me an idea. Scene step. Damn. I feel so fucking smart. Oh, let's define a function called a scene step. Right, it's analogous to a smooth step, but it uses sine function because it has nicer parameters for our specific purpose. So, or something like that. I don't fucking know. Those step. Those step. Dubstep. Haha. So, okay, so it doesn't fucking work. Tape count. Oh, I actually make it like this. Tape. And tape now is a part of this thing. Oh, right. Okay. That's pretty progress. Wait. Oh, it's now a freaking. Okay, I see. So let's do from. Okay. I never knew I needed sodding beatboxing to dubstep in my life until now. Now you know. I didn't even know how much it sounded like a dubstep. I just did a little bit of a vocal fry, and just added a little bit of like a kick and snare, right? So isn't dubstep is like a basically waltz? Basically, isn't it? I don't know. I don't have a musical education. I have unfinished musical education, so I wouldn't consider myself a musician. It's a double time two-step. Oh, I see. That doesn't tell me anything, but I believe you. I actually believe you. So, and by the way, now what we can do, we can basically synchronize our entire animation sort of to the phase of the head. The phase of the head. I think the only requirement is that wobbly sound. No, there is like triples in there. I don't know how you say it in English, but there should be like this. Something like that. Anyways, I hope my neighbors are. Fuck! I just realized that it's the middle of the night. So, fuck. And then I am the one who's complaining about noisy neighbors. Anyways, cheers. It's the rhythm of the night. Yeah, it is. It fucking is, mate. It fucking is. So let me see. So we have animation value, we have all of these shices. So I think I'm gonna just straight up removal of that and go to the compilation errors. You didn't do much noise. How do you know that? How do you know that? You're looking through the lens of my microphone. Doesn't make any sense, but I mean, you get the point, hopefully. Right. So here we just do that. So this is the animation. Okay. What I'm thinking, let's get rid of that stuff as well. Depending on the phase, so we have to look at the head. So maybe we're gonna do a little bit of a switcheroo. So head phase, so and then we're gonna have HP moving, break, HP writing. Cool. If we are in a moving phase, all right, I'm a little bit scared now. So let me see. I we're a little bit, so plug init. So this is a plug init. We initialized all of these things, and I probably want to take the head and puts its face to HP moving. And where we're going to be moving in here? We're going to be moving from 0, from maybe 7 to 8 or something like that. What is Manim? It's an animation framework that 3Blue1Brown uses for his mathematical videos. Right, I really recommend you to check it out. Manim, like this. So he wrote that in Python, right? So I think he open sourced it. So I don't really know what's the relationship between the Manim that is actually used by 3Blue1Brown and developed by 3Blue1Brown and this one. So does he use that one, or does he have his own version? Does anybody know? So because I think he has a GitHub, 3Blue1Brown. We can always check out like what exactly does he use. He has his own. Okay, I see. Oh, he turned into organization. Damn. Grant turned into organization. So this really. What the fuck? Where is he? Damn. I remember he had like an account or something. Alright. I don't know. No, don't really know. So there's no people in here, so yeah. He has no public members. 3B1B. Okay, let's check it out. 3B1B. That's his account. Damn, he's got some sexy account. 3-letter account. Like, when did he joined in 2015. And he still got that sexy account. Maybe he actually joined. Yeah. I personally joined in 2009, by the way. So 4 and 3, I'm sorry. Yeah. So if you take a look at when I joined, yeah, 2009. That's when I joined to GitHub. I'm an OG GitHubber. OG GitHubber. You're also organization. Am I? I don't think I'm an organization. Anyway, so he's... Yeah, so animation engine for explanatory math videos. So he has his own one. But since it's open source, people just took this thing and sort of forked it and made their own, like a community maintained version. So Manim is an engine for precise programmatic animations designed for creating explanatory math videos. Note that there are 2 versions of Manim. This repository began as a personal project by the author of 3Blue1Brown for the purpose of animation, those videos with specific code available here. In 2020, a group of developers forked it into what is now a community edition. Okay, a community edition, a separate thing. All right, that makes sense. With the goal of being more stable, better tested, quicker to respond to community contributions, and all around friendlier to get started with. See this page for more details. This is actually a very cool idea. Right, so it's just like he's not gonna be doing open source maintenance. Like, he has no time to do that. Absolutely, right. So it's better like that somebody else does that. So he has his own sort of version he maintains and stuff like that. And for everyone else, it's just like this thing. And I suppose maybe they once in a while incorporate his changes from here or something like that. But that's a very cool dynamics between, like, you know, between him and this community and stuff like that. So that's pretty cool. That's pretty cool. So I'm gonna start this one as well, right? Because I started this one long time ago. I remember that, right? So I think I started way before like my community edition existed, but I'm gonna start this one too. Pretty cool. Pretty cool. And the reason why I'm making my own one is because I just don't want to learn Manim. So what's funny is that it's kind of funny. Like, I reached the point where it's simply easier for me to just develop my own thing from scratch rather than learning someone else's software, right? So to learn someone else's software, you just like, you have to read documentation, you have to spend so much freaking effort. It's easier for me to just like write the code that does the fucking job. Like, it's just like, yeah, whatever. Because of that, I'm writing this thing. It's like, it's easier for me. Like, I know exactly what I want. I just write it down and make the computer do the thing, rather than learning someone else take on the problem. because that's what it is. Someone else's software is just someone else's take on the solution of the problem. And now I have to study that take. I have to internalize that take, right? And stuff like that. I want to do that. I have my own take on how to do this shit. So I'm going to just write it down. And no limitations and stuff like that. Yeah. So anyways. And maybe this thing will evolve into something else. As far as I know, my name is like uses heavily like OOP features of Python, so it's pretty much like an OOP-ish framework, right? So here we have a very imperative thing instead. So I wonder how this thing will evolve in the future. We'll see. Right. Okay. So what do we have in here? So this is T. Cool. Yeah, so we have different phases and stuff like that. So if we are moving, right, if we are moving, what I want to do is basically, yeah, what if I factor out this entire thing to just a separate function? I don't know how to call that. Turing machine. Let's call this Turing machine. But maybe... because this is already the Turing machine, so I don't freaking know if I want to factor it out. Right, so I'm running out of names for functions to call. But anyway, maybe, honestly, I can just render it in here and update the actual thing somewhere here. Yeah, that kind of makes sense. So essentially, we just have T in here, which is going to be initially 0. And if we are in the moving phase, what do? We take head, right, and since we're moving from to to, I just do from and to, and we need some sort of a parameter. So this is going to be head moving duration. Right, it's going to be half of a second, right? So this is a half of a second. So that means I have a T. And T is an interpolator from 0 to 1. It is interpolated from 0 to 1, so that means what I want to do in reality, I want to map it from 0 to the duration of the entire thing. Then I want to add the frame, not really the frame, but delta time. Delta time is actually passed in here as the parameter. Okay, so that makes sense. That's very cool. And then head moving duration. So I mapped it, I updated this entire stuff, so then afterwards I can divide this entire stuff back by head moving, and that's the new value for the T of the head. Right, so that's the new value for the T of the head, which I might actually assign to T, but T is going to be more like the actual position of the head. So essentially what do we do? So this is the interpolator from 0 to 1. So I take head, you know, from to both of them. I want to actually make them floats in here. So these are the floats. Then I want to multiply this entire thing by that, but maybe I'm gonna also do scene step in here. I think scene step is very much useful in this specific case. It's a little bit weird, but I mean, that's fine. So there's also a situation when this thing becomes greater or equal to 1. All right, if this thing is greater or equal to 1, that just means we're done with this animation, right? So what we have to do now is we have to switch from to, and we have to switch the phase. We have to switch the phase to HP writing. So that's what we're doing here. And in HP writing, we assign T P head from like this. It's gonna be float, and we just reuse that T for the rest of the things. Okay, so that basically moves from one place to another. Okay. So okay, so we don't need animation anymore, so we're kind of getting rid of the animation thing at all. So maybe might as well just get rid of these things completely. And yeah, something like this. Simulating all of these objects that I want to animate directly is actually way better in my opinion. It is actually way better. Okay. Oof. So rendering duration, that's totally fine. So when we are resetting this entire thing, so maybe the way we reset is going to be basically redo that entire thing. I really like that. So let me do the following thing: reset animation, and I'm going to do something like this. So all of that is related to the animation. So we load resources, we reset animation. That's cool. So we do that, and in terms of the p head t is, we're gonna make it equal to 0. So, and now every time we're sort of like setting duration and stuff like that and resetting this to 0, what we can do instead, reset animation, and just reset animation. Reset animation and reset animatione. What else do we have? Turing tape. Okay, so this is the function. So it's just called Turing machine, the one that we're animating, and we don't even have to pass anything. We just pass delta time, fixed delta time because we're producing the video, fixed width and fixed height. But since we are like sort of decoupled width from the specific parameters, we can actually quite easily customize all of that. So, right, and here is the similar thing, but here, since we're previewing, we take in the frame time and of the window, width of the window and height of the window. Right, so look at that. So, it's not a tape. Look, so this is when we're producing the video. All of these things are fixed, and this is when we are previewing. So, but this is the same function, right? But in one case, the parameters are hard-coded, right? Because it's a video, like a specific video. And this one is dynamic thing, and because of that, we're taking these things dynamically, right? So this function doesn't know whether it's rendered on a window or it's rendered in the video. It's kind of similar to Visualizer. We had the same problem in Visualizer. It's the same solution, essentially, just abstracting away that. Essentially. All right, so what do we have in here? And that seems to be compiling. That's pretty cool. That is very, very cool. And when we're in a writing state, by the way, we should be probably animating the, you know, the head, the cell, specific cell. So we need to be animating this specific cell. How are we going to be doing all that? This is actually kind of interesting. So we're switching to 2. And as we go to 2, maybe that's fine. Okay, let's actually see if like a single iteration, it actually went backwards. Did I really freaking coded that? Yes, no, I didn't. So we went from 7 to 8. So it went backwards. What? Am I an idiot? I think I'm an idiot. Yeah, I think I am. From, so this was from, I don't see from, yeah. So when I'm interpolating, yeah, why am I subtracting this entire stuff? Why am I subtracting this entire stuff? I suppose what I have to do is then, so 2 from, that's the distance between them, and then I have to just add this entire stuff like that. So that's what I want to do in here. Right, so that makes sense. Okay, so one step is actually moving like to there. One step is actually moving to there. So we also have an offset, an annoying offset that we probably don't need because I already baked that offset in here, so it is not needed. So now, if I just do that, all right, that's cool. That's very cool. And I started rendering. I should have not actually started rendering. Okay. Where is my stuff? Where is my stuff? Just a second. I removed the offset, right? I removed the offset. So now, yeah, it's in the perfect place. It's actually here. Cool, cool. So now, what I want to do, chat, what I want to do, I want to basically start updating the cell. If I'm in a writing, I'm updating the current cell. I'm updating the current cell. So essentially p tape head. So we take head from, that's the current index of this entire thing. It's already initialized with from to 2, but just in case I want to initialize it 0, right? So this is basically what I want to do. All right, so in here, when we are writing, we take this thing, and we're gonna use head moving duration. It's gonna be the same duration for writing and moving, right? So we're gonna use the same thing, and we're gonna just update this thing. We're gonna add it like that and remap it back like this, and reassign it back like this. There we go. So that's what we do. Cool. And at some point, right? At some point, this thing basically becomes greater or equal to 1. And we have to switch to a different situation, right? So we have to switch to this different mode. So we're going to do head from whatever we are, but we're going to be moving to head from +1. We're moving to the next one. You see what we're doing here? You see what we're doing? That's what we're doing. So, and then we're going to reset the heads interpolator. And we're switching the heads phase to HP moving. Right, so we have some sort of like a state machine in here, you see? Right, we saw the state machine. So it's kind of better, right? So we can do these kind of things programmatically and stuff like that. I really like that. I really like that. Okay. And then that will bring it back to here, right? Bring it back to here, and it will move to the next one, then switch back to here, and it just like flip-flops between moving, writing. And here is the funny part, right? So we need to use that interpolator within the cell to properly interpolate the text, right? To properly interpolate the text. So we have the text from. So the bigger. So if it's 0, it has to be from. If it's 1, it has to be 2. So the bigger the value, the more faint the sign from has to be. So I actually want to call this from text. Right, so this is a from text. Right, so because we're going to have 2 of them. We're going to be rendering 2 of them, in fact. So the measure text, and this is just a from. The way I want to do that, actually, is maybe this is the font size. So maybe I can take tape I and it's T, and I can invert that. So that way, the bigger the value, the smaller this thing will become, and I can effectively maybe multiply this entire thing by the font size, so it will shrink. So as the animation goes further, it's going to shrink. All right, so are we still playing? No, we're not playing. So now if I try to run this entire thing, and I'm gonna try to do that. Aha, I see what's going on. So it kind of worked. I really like that. So we can do font size, which is going to be float font size. We're going to assign it in here, and the font size in here. Right, so it just offset it a little bit. Right, so let me see. I think it's going to crash at some point. you know, that's why you program in Rust, by the way. So that's why you program in Rust, because it literally went out of bounds. It was so fucking cool. It started to become glitchy because it started to corrupt its own memory. We literally saw buffer overflow. What the fuck? Because we were rendering the buffer, and then we didn't have like a out of bounds check, and it started to corrupt everything, and it just eventually fell apart. What the fuck? This was so cool. I want to see that one more time. I want to see that one more time. This is what Rust developers want you to miss. If you program in Rust, you're missing all of these beautiful educational moments. You're not gonna learn about any of that stuff. Rust developers don't want you to see any of that cool shit. I'm telling you. I'm freaking telling you. Anyway, so let's actually start that one more time. So we're consuming 69s. We are just consuming 69s. Right. Such gatekeepers, I swear to God. True, true. Look at that. That is so fucking cool. I love it. And it just segfaulted. Yeah. So it down below it said segfault. Okay. So one of the things we can do. We can maybe introduce another thing in here called halt. And I wonder, by the way, is the compilation is going to no, yeah, it's actually warn me. So that's cool. That's cool. So halt case HP halt. All right, and in halt, we just do that. So if if this thing is greater or equal than the tape count, we are simply switching to head phase HP halt. Otherwise, we are going to the next one. That's cool. Let's see. So halt should just stay in place and don't do anything. All right. Okay. No buffer overflow. No buffer overflow. That's pretty cool. Okay. So now what we have to do the same thing, but for the to text. Right, so let's actually do query replace from to, boom. And in here, font size is not going to be reverted, right? It's going to be the opposite of being reverted. So this is the position. To be fair, maybe I should actually put them in separate scopes, right? So because we defined kind of the same variables in here, so it would be better to actually keep them in the same scopes. Let's go. Okay. It looks kind of shit, honestly, but because they overlap with each other. But I think one of the things we can do is maybe make them more transparent over time. So this is just this thing, right? This is just this thing. So this is going to be my own sort of queue, right? So, and I can assign this thing in here, and this is going to be like that. So then I can take the text color. So I'm using the background colors, but one of the things I can do is color, I think color alpha. Do I have, yeah, okay. Oh, it's probably like that. All right, so then I can use Q in here. Let's go. Okay, so it not only shrinks down, it also becomes more transparent. That's what happens. So we can do a similar thing in here too. So this is going to be just the Q, float Q, like so, and we can do color alpha like so. This is Q. Looks great. It's fine. It could have been better, honestly. Oh, that's actually epic. That's much better. Pretty sexy, not gonna lie, yeah. Pretty cool. Cool. By the way, I was always like wondering, when do I stop the rendering? When do I stop the rendering? Now I can just look at the phase of the head, and if we reached the hold, that's where I have to start. Like, I don't need the render duration anymore. I can just say, okay, if p head phase equal hp hold, essentially. So we're kind of already writing like a Turing machine simulator at this point, but that's fine, I guess. It's kind of funny. All right. So I wonder for how long is it going to go. So all right, let's just try to render it. A render duration, we don't need that stuff anymore. So let's go to the compilation. Did I really remove that? Plug. Yeah, we don't need that stuff anymore. So let's actually. Got you. We don't need that. Cool. So. So this is between that, but it's actually such a small thing that I don't think I need to indent it. Overall, it looks nice. Overall, it looks nice. I'm really happy with how it turns out, honestly. Super happy. So I'm thinking that maybe all of the code that is responsible for rendering and previewing should be outside of the DLL. Maybe DLL should only contain the code concerned with actual rendering, but I'm not 100% sure about that, like how exactly we're going to pull that off. For now, I'm going to just keep it inside of DLL. Right, so, and we'll see. All right, let's render it. Okay, so, and we're rendering. I don't remember how... It renders pretty slow, honestly. Maybe that's fine. So let's just like wait for a little bit. Let's wait for a little bit. So, and while we're waiting, so maybe does anyone have any questions while we're waiting for this entire thing to render up? Right, so you guys have any questions about what I'm doing or anything I'm just doing? Oh, we're done apparently. But feel free to ask questions, I suppose. What's your opinion on Scene 23? I don't know anything about it, honestly. I don't know anything, but I didn't check it out, and I don't really have any plans to check it out. Right, so don't really have any plans. So I think it's fine. Yeah, I can close it now. So it renders at 60 FPS right now, it's 30 FPS, but we can make it at 60 FPS. It's configurable since you're rendering one frame at a time from Rayleigh. And not really, actually not really. So we just render the frames as we can. Okay, so here's how we're doing that. We tell FFmpeg that we render at 30 FPS. Then, while being within the FPS of Rayleigh, we render one frame at specific timestamp, and we just send that frame to Rayleigh. Then we update our timestamp with, 1/30. Right. So we're simulating the game, the animation at 30 FPS, while Rayleigh still being at 60 FPS. The simulation during rendering, during sending frames to FFmpeg is independent from actual FPS of Rayleigh. So that's how it works. So the FPS of Rayleigh becomes irrelevant. We're simulating at our own FPS. We will check a new language Glim. It's just like, beam-based language. Is that what it is? Sounds very boring, honestly. The goal is only the Turing machine animation, right? After that, make a lib generic. I don't know. We'll see. So to make the lib generic, you need to have a lot of specific cases so you can generalize them, right? So I don't think I have too many generic cases. So what is OM? I have no idea what the fuck is this. All right, let's take a look at the animation. Okay, so that's the actual video. Oops. What the fuck is this shit? Excuse me. It started pretty great, not gonna lie. It started okay, but what the fuck has happened? What the fuck? Like, it's so bizarre, actually. It's so bizarre. Like, what? Like, it started okay, so this is fine, and then it's just like it went haywire. So you were passing wrong width and height. Maybe I was. I don't fucking know. So screen width, render width. It shouldn't matter though, but yeah, let's actually see what the fuck is going on. That's so bizarre, honestly. That is so bizarre. So we have width and height. Okay. Okay. So let me take a look at all of the places where we use all of that stuff. Data time is probably doesn't matter, but yeah, anyway. Okay, so width and all right. So what else do we have in here? If I take a look, get screen width. Okay, get screen height. Okay, so that's the only places where we call to these things. That makes sense. That's pretty cool. By the way, can I just like no, I can't. Right, I was thinking maybe I can copy paste the progress bar from Visualizer, but in this case I don't really know when animation stops. Right, so I don't know upfront because it's sort of programmatic like that, unless I can solve the halting problem. Anyways, all right, let's go. Let's render this scheiße. So maybe a more generic question, but how do you determine whether to make a library or to just write the code? If I want to reuse the code, I make it a library. What do you mean? Or to just write the code? It depends on the situation, honestly. So is something lagging? Are we lagging right now? I don't really see that we're lagging. So it really depends on the situation. You don't have like a generic rule, right? So if you look at the situation, what do you need? Do you need a library? Okay, you just make a library, right? So you just use a library. Do you need to write code? Then you just write a code. So there's no like magical answer to any of that stuff. So I don't know. Okay, what do we have here? Let's go. And I also looped the MPV. So yeah, this is the video and it's working. It is working. I can now maybe import it to Blender or something like that. I can add more different things in here. So yes. So I think today's stream was actually extremely fucking productive, mate. Extremely fucking productive. All right. So let me actually commit whatever I got. Right. So we have these images. Oh, I have Tsodin Zezin here. I guess I'm gonna commit it. Okay, so let's actually commit it. On top of that, I think I want to git ignore the MP4 files, right? So this is gonna be MP4, and that's it. So add support for FFmpeg and make the animation more programmatic. There we go. Right, I'm gonna push that. Right, do I have the repo? Yeah, I do have the repo, but it's private as for now. All right, I guess that's it for today. Thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you all on the next recreation programming session with Mr. Azuzin. I love you all. Mwah.